Last time when we were looking at section 2.2, we had gotten to the point where we were talking about some different graphs and how to draw their slope graph or their derivative graph. Our basic principles that we had looked at are written here. The goal is to be able to start with a graph of a function and then draw a graph that represents its derivative at every point. And specifically, we looked at three different ways of describing what's happening on the graph. The first was to find where the slope is 0. The second, where the slope is positive and or negative. And the third, how the slope is changing. We had done, I think, 4 examples last time, and we were on the 5th one, which is problem number 7. So in particular, here's the graph we're working with on this one. We're doing the same thing as before, looking at where the slope is 0 and so forth. So we'll notice here on this graph that the slope is almost 0, kind of like on our last one. We'll say on the far left or on the left. And the slope is actually 0 in a few locations. In particular, notice it's 0 about right here at, looks like 3. It's 0 again right here at 4, and not only at 4, but everything actually between 3 and 4. And then again between 4 and 5, and then at 5. So the slope is 0 at, I shouldn't say it at 3, that was not said correctly. Let me actually go back and fix that. Let's take a look at that again. All right. What happens right here and right here? We have a jump in the graph, right? Okay, so when there's a jump in the graph, we actually have a discontinuity, and slopes do not exist when we have discontinuities. That is, the slope of the tangent line doesn't exist, the tangent line. So we actually don't have a slope that we can talk about specifically at 3 or 4. But those particular intervals we were looking at between 3 and 4 and between 4 and 5, those are values where the slope is 0. So the slope is 0 from 3 to 4 and from 4 to 5. Alright, so that's all our issues about slope being 0. So the next thing we're going to do is we're just going to move from left to right on my graph and talk about how the slope is changing. So we'll notice that from negative infinity, the slope is negative from negative infinity to 0. It's also actually negative from 0 to 3, right? It's still decreasing the graph itself, so the slope is still negative. And then we already have the pieces from 3 to 4 and 4 to 5, so that's interesting. We don't actually have any positive slopes on this one. And the last thing to notice about the changing business is particularly around the y-axis. So around the y-axis, we actually have very, very steep negative slopes. So in particular, the slope becomes very negative or more negative as we move from negative infinity to 0. And again, slope becomes, and in the other direction, less negative, so smaller negative numbers from 0 to 3. Alright, so in terms of a graph, what does that look like? Well, let's take a look. We're going to try to get sort of the same x, y values as we did before. The x values are more important. I'll just put this in the middle to kind of give us a little bit better of a perspective. And I'll mark a few of the x values here. Alright, so I'm supposed to have a slope that is very close to 0 but negative on the left-hand side and becoming more negative as I move from left to right. So it'll look something like that. And again, then as I move from left to right, going from 0 over here to 3, I become more negative, and actually I'm pretty much hitting like the x-axis here. And I'll draw an open circle because I know the graph doesn't actually have a derivative at 3. Now from 3 to 4, alright, so from 3 to 4, we're along the x-axis because the slope is 0. At 4 itself, the slope doesn't exist, right? The derivative doesn't exist. And then from 4 to 5, again, we're along the x-axis from 4 to 5. The graph at 5 actually looks like it ends. So some people would actually say that we have an open circle here. You could say that it's a closed circle because there's not actually a jump on there as well. It definitely has a one-sided limit at 5, so most of the time you'll see that 5 circle filled in right there. All right, one last question in this section. Question number 8. This is one of those ones where my answer may be different than your answer, may be different from somebody else's, and we could all be correct. And there's some details on here that actually have to be the same between our graphs, but not every detail. All right, so let's take a look. The question says that we're going to sketch the graph of a function with the following properties. So these are the supposed function properties. Some of them are function notation like this one. Some of them are derivative notation like this one. So we want to be careful to notice those things. The first one says that f of negative 2 is equal to 2. So that is a very specific piece of information that tells us we can plot a value of y equal 2 at the x value of negative 2. So there's our value right there. The next one says that f of 0 equals 3. So we're going to plot the value of 3 at x equals to 0. So this is where we are right here. So those two pieces of information are going to be the same on all of our graphs, and then one more of them as well. At at x equal to 4, f of 4 is equal to 1. So these 3 points are going to be the same on all of our graphs. The next 3 pieces of information are a little bit looser. In particular, this one tells us that f prime of negative 1, that my slope is 0. So what does that mean? Well, it means that somewhere at negative 1, I have to have either a peak or a valley. So my graph could have a peak and yours could have a valley and it would be the same. Or my valley could be higher or lower than yours and be the same. So the way that this is actually interpreting, I need to have a 0. So maybe for now, and I may go back and change this later, it looks like this. So that at 0, or at negative 1, I'm at a slope of 0. The next piece tells me that at f prime of 2, so at x equal to 2, right here, right, I need to have a slope value of negative 3. So slope of negative 3 just means that the graph is decreasing, right? Now I know it's very specific. It actually says negative 3. The negative part is the part that we're caring about, is that as we are at 2, the graph is decreasing. In other words, something like this, maybe. Or maybe it actually just connects these two, so something that looks maybe like, let me go back actually, and I'll change how steep my graph is, because it may be a little bit smoother to do something like, hang on, like that. I do need to connect them though. Alright, so maybe it looks more like this, or maybe it looks like it's going to continue to cut down and through. My graph's a little bit spread out on my x-axis, which is part of the problem as well. Let me see if I can sketch that a little bit cleaner. Move these a little bit closer where they would be. You know what? The graph is supposed to be going downhill, but I'm going to actually give another option. I think it might be easier to draw if I do this. Let me do that. Oh, I like that better. Here's my 0 slope. Sure. This would actually be my slope of negative 3. It's a little bit easier to draw that way. Let me see, a little bit further in right here. And then I'm actually hitting the right points. Yeah, that would work. The other graph I was drawing would work too. I was just getting a little bit squished up in my scale and it looked a little bit funny. So this graph has all the features, right? I have the 3 black points that I originally started with. The slope is 0 at negative 1. And at positive 2, my slope is at least negative. Is it exactly negative 3? Well, I don't know for sure that it's exactly negative 3, but it's at least negative, which is a sketch version of what we're kind of looking for here. And again, your graph might look a little bit different than this. As long as it has those same features, we're all in good shape.